Next part of the discussion is versatile nature of carbon. If you go for the versatile nature of carbon, actually it was Berzelius. Berzelius was under the opinion that any organic compound is living in nature and compounds and all inorganic compounds are non-living in nature. But this concept of Berzelius was given a death blow, and according to the Berzelius, he is under the opinion that because living substances are organic in nature and non-living substances are inorganic in nature, any organic compound, if it is living in nature, then that living in nature for the organic compound is studied in the form of vital force theory. This was studied in the form of vital force theory. So Berzelius was under the opinion that any substance, if it is organic in nature, it is living in nature. The living in nature of an organic compound is according to the vital force theory. That means a substance, if it is having certain amount of force in it, that force is expressed in the form of living nature of the compound. So all organic compounds, they are living in nature because they have some vital force theory. Based on the vital force theory, they are living in nature. But if you go for all inorganic compounds, they are non-living in nature. So because they don't have any vital force in them, they are treated as the non-living compounds according to Berzelius. He was under such opinion. But this opinion was given a death blow by Friedrich Wöhler. Friedrich Wöhler, he gave a death blow to vital force theory. He gave a death blow to the vital force theory, and he discovered first organic compound. Friedrich Wöhler has discovered the first organic compound from ammonium cyanate. That is NH4CnO, ammonium cyanate. According to Friedrich Wöhler, this ammonium cyanate, when it is subjected to isomerization, upon heating, it gave, that is NH2CO. This is called urea, and this is ammonium cyanate. Apart from urea, many other organic compounds also, they were synthesized in the laboratory. Other compounds synthesized is formic acid, acetic acid, alcohol, and so on. These are some of the compounds which are synthesized in the laboratory. These two compounds are synthesized in the laboratory. Formic acid and acetic acid. So the next part of the discussion here, apart from the synthesis of organic compounds in the laboratory and first organic compound which was discovered by the Friedrich Wöhler, actually this carbon is given a special status in the organic chemistry because the carbon is an element which is unique, and we have studied its properties in the earlier discussion. Now if you go for this carbon, if it is so unique, it is also showing one important property called catenation. Catenation, if you take that is interlinking of carbon atoms in straight chain, either in straight or branched chains. Branched chains is simply called as, that is catenation. Now if you go for catenation, for carbon, catenation is unlimited, because as already I told you, interlinking of carbon atoms either in straight chain or in branched chains is called as catenation. If you go for catenation, carbon has the tetravalence property of showing the catenation. It is tetravalent. It can interlink itself in the straight chains like this, or it can go in the form of branched chains also. Like this. There is no specific condition for the carbon. It can interlink in either way. This is called interlinking of carbon atoms either in straight chains or in branched chains. So there is no limit for the catenation power of carbon. But if you go for other elements, for example phosphorus, if you take phosphorus, it is P4. If you take sulfur, it is S8. So catenation power, Cp, catenation power is 4 for phosphorus, catenation power is 8 for sulfur. That means the maximum catenation power, if you go for nitrogen, that is N3H, hydrozoic acid, its catenation power is 3. So therefore if you take the decreasing order of catenation power, if you take carbon has more catenation power. If you take carbon has more catenation power, then that is for sulfur has more catenation power than phosphorus. So for carbon the catenation power is unlimited. For sulfur the catenation power is 8, and for phosphorus the catenation power is